So let's look at the different tools, cutters we're going to be using. Let's go down here and we'll just click this and look at the tools. So we have, as I mentioned, we have 3 ball mills. We have a 3/4 inch ball mill, a 1/2 inch ball mill, and a 1/4 inch ball mill. And our smallest ball mill will be the finishing pass, which will leave an 1/8 of an inch fillet down along this edge. Okay. So we got 3 ball mills. We have a flat end mill that we're going to use for roughing. And we also have a corner radius mill, sometimes called a bull mill, which has a flat at the bottom, okay, and a corner radius of 125, which is the same radius as the 1/4 inch ball mill that we're going to be using. And I know if you've heard us and how we recommend to do different types of operations in horizontal roughing, we always recommend that you use a flat end mill if possible, because it's going to calculate a lot faster, so you'll get through the actual programming faster, and it's actually going to cut faster. And we recommend that you don't use a ball mill for roughing or a corner radius mill for roughing, but there's always exceptions. In this particular case, in order to get what we want right here along this edge, we are going to use a corner radius mill. And if you've also been to our webinars, we try to show you different ways of using different operations, which may not be readily apparent to you. So what we're going to actually do is we're going to use a horizontal roughing operation with a corner radius mill in order to get a perfect fillet along these bitangent areas here. And that's something we're going to show you in detail. Okay, so those are the cutting tools. And let's take a look at some of the preferences that we have set. Stock, we've just set some colors for our stock material. And we have edge is going to be highlighted, which you can see the edges. Cutting tools, we just have colors for those. Standard feeds and speeds. We're not going to be actually recommending any feeds and speeds. If you've seen our webinars before, we're not ever going to tell you what feed rate to use for a particular tool, because that is something that you have to know specific for your machine, your cutting tools, your materials. So all of these feeds and speeds are going to be the default values. For the machining, we're going to do a part sampling resolution set to fine, and we got a minimum arc radius. We don't have any really large arcs here. Output control, we're going to be outputting arcs. Okay, we're going to turn that off. For toolpath, we just have different colors set, and we have the thickness for the toolpath set so we can see it very well. For simulation, we've got the simulation accuracy set to fine, and we got the simulation tolerance set to 5,000. Okay, and then we have a stock model display transparency. We have that set in the middle between opaque and transparent. User interface, all these are pretty much the standards here. Post-processing, that's pretty straightforward. Okay, so let's go ahead and get started. Now I actually have another screen over here that I have this part fully programmed on, so I'm going to be referring to that as we program this part. So for any CAM operation, as I mentioned, when you start, get to know your geometry. We went over the geometry here for this part. In your geometry, get to know what these radiuses are, because your finishing ball mill will need to be that or smaller radius. Okay, so we got a number of radii here, and we got a number of section curves that we've cut just so we can. We looked at the drafted angles here based on the sections, so you can cut those using Rhino's sectioning commands. So we got the section curves, and we're going to start over here from the program tab. And again, I want to point out, if there's something that we didn't cover, you want to know, just put it in the the questions panel. So the first thing we're going to do